Students will be presenting at this time. That's fine. You just won't see the viewers.
All the parents can start sitting. If you want, we start at 10:30. You can also sit in the background. And we start at 10:30. Yeah. Yeah. So you want that?
Everyone helps setting up the manual.
Okay. So. Similar for this region on here. So which is now. Will be managing everything in the background. Let me start everything over here. Pick 0 day slides. Very well. Yeah, it's not ready. She's working 7 minutes from the idea to go and go. What is the agenda? The agenda is straightforward. Presentation. Presentation. Ask Arjun, put the backup generator outside and ready to fire up. grab the bottom of that. Let's just move this outside on it. From the very bottom. You see the metal frame?
Connect the laptop and not drive.
This one goes outside, okay?
भाई आप लोग लग गया
Remove this.
The presentation that they're going to present. What? Why?
I'm going at 11 o'clock. Flights are
I genuinely got a coach. You can do it as even things like me, you and Sabya got to study. Mine is not even presentation on it. I'm already doing this.
You can just have the name of the team, don't worry about it. Where is the remote for the projector? Sebi, do you know where to put this on? This one? Yeah. Put this on. Yeah. Okay. Yeah, yeah. Open up the door. Move it back. Wait, we just changed teachers in 2 seconds.
I've shared the presentation order in the team.
You've been wearing this Do we have the parking lot? Yeah. Is there space now? Yeah, it's. Four and five. No, not here.
Don't walk faster, walk slowly and okay, for that
first residential without any.
Sir, have you seen Levan?
Call?
Do not have that one. Wait, he's right there. I can see him. Levan.
Yeah, even I. When it was failing now.
You can tape it. It's double-sided tape.
It's not.
You can peel it off.
Not really.
Did you take your T-shirt also?
No.
May I have the team name, team number and name?
22. The spectacles.
22.
Arya. Arya.
I'll get it.
I swear it's perfect for all.
I was gonna do that.
Should we give the medals to the parents first? You guys will cover on the back.
You need extra wires.
Come to the benches. Help me get some chairs on the back. Come here, help me get the chairs on the back.
Have a seat, everyone.
Sorry, everyone took the chairs out for the market. Move them back again. Sorry about that. Well, welcome everyone to day 0 of the program. How do you guys feel? Woo! It's been a week already. I hope everyone had a good time in Goa. Hope parents had a good time. Nice, good. Because your sons and daughters were with us doing a lot of hard work. I think you'll get to see some of it today. It's a really exciting, but at the same time, it's a very intense one. It's quite an intense week. You guys get about it? Some good feedback? Okay, good. Well, there's a reason why we call it day 0, and I'll talk about that. Somebody move the wire. Sorry about that. Hello. Sorry about that. Well, there's a reason why we call it day 0. Day 0 because we hope that this is the beginning of all of your maker journeys and not just the end. It's hopefully the beginning of a journey of doing a lot more tinkering, a lot more breaking projects, a lot more making projects. I think in the last couple of days we've gone through a lot. Let's just quickly take a look through what's happened. I sent a group link of all the photographs as well, but I want to take a look at a few of them. Do you remember this? We met each other in a very awkward manner. Nobody knew each other. Everyone's here from 6 countries this time. and 10 cities across India, so all over. Look, a lot of us did not know each other, so we were meeting for the first time. And we played a game called, well, actually a very interesting thing. We made 2 circles and we listened to a gong sound and went around. You guys remember this? How awkward was it? But after that, did it help anyone break the ice with each other? No. Yes. A lot of awkward faces. Okay, this was an exercise that we learned. One of our mentors learned from the Dalai Lama. He had the opportunity to spend a lot of time with him in the mountains. And since then, it's been a staple for us because there's a lot of positivity that we're able to pass into each other's eyes without speaking. We learned a lot of tools. Everything from all the hand tools and the power tools. How many of you feel comfortable with tools now? Oh, that's good. How many of you feel comfortable with power tools? Okay, good. So we learned a lot of tools, and we learned the right way to use a lot of tools. We talked a lot about what kind of tools can be used when, not everything. We learned a lot of power tools, the big ones that you see inside the shop. And I think I'm very happy with every one of them here, because everyone used them with a lot of confidence. And now I can say that they're okay to go inside the shop floor with more confidence. That's what's really important. Back in the day when I went to college, I had no idea how to enter a shop, what to do, what not to do, what to expect, what are the safety rules. And that's really important to get a grasp of, to understand how do you do in a shop like this. It was beautiful to see them work, beautiful to see them use everything, make things happen. A lot of them had time to explore new things, new projects. How many of you managed to make a project beyond your project? Or anything small that you're thinking of? Few of you? How many of you end up making your stamps? Finish your stamps? Okay, that's good. So we're trying to do more things beyond just the project to be able to get used to making stuff. Okay, how many of you managed to help some other team? Or get some help from another team? Let me ask that question. That's a better question. That's good. So many more hands from day one. Okay, hopefully you had a lot of fun. Got to meet a lot of people. How many of you made new friends this week? Okay. Nice. How many of you got frustrated and confused this week? Listen to this one. Nice. How many of you managed to break something this week? How many of you experienced a little bit of failure this week? Good. That's awesome. Because those are the things that are really important to be able to learn something new. And I think that's what was really key. Oh, how many of you witnessed Murphy's Law? There you go. For all the parents, do you want to tell them what Murphy's Law is? Or Lord Murphy? Okay. Go ahead. Anyone wants to tell them what Murphy's Law is?
Start it up.
Okay, let's do it together. Anything that can
Go wrong, will go wrong.
Thank you. Anything that can go wrong will go wrong. So I think that's the life of a maker. Whenever we make stuff, everything that can go wrong will go wrong, especially when it's presenting in front of all of you. Everything will go wrong. So let's have zero expectations from the presentations. Let's have zero expectations from the prototypes. If something works, that's awesome. If it doesn't work, it's meant to happen. It's meant to not work. We also had a board game night. I think it was a lot of fun for us. We got to meet them beyond the program. I had the opportunity to play a lot of games with a lot of them, so it was really fun having them around. Thank you for sending them. Plus, we met some amazing mentors. Some of them are here. Can you hear it for them? Let's hear it for where is Sahil? Okay, let's hear it for Noor. Nice, and I think Archit and others are not here right now. Bihan, but let's just hear it for them, they'll hear us somewhere. Bihan and Archit. Nice. It was super fun getting to know them and at the same time bringing them down. It's always nice. Okay, now without further ado, I'll talk a little bit about things later. But let's hear from all of them because that's what we're here for. The stage belongs to them today. Once again, the rules of the presentations, you guys have about 5 minutes, okay? Try not to go on. Spend 5 minutes. We have a lot of teams who want to make it exciting, make it super fun. Okay, with that, let's call upon the first team. First team is Transformers. Are you guys ready? Oh, sorry, Transformers. Transformers. Transformers, are you guys ready? Present? Let's go. First team, Transformers. Oh, they wanted to go second, right? Something happened with them. Okay. Okay, then let's go with Green Forge. Are you guys ready? You guys are presenting over here. Get your prototype. You have a presentation? That's all right from here. Okay, your presentation is over. Just turn that on and okay.
Check.
You can tell them where you're from as well and also your name. Oh, we forgot. Okay, but we can start. Go for it. Start by introducing yourself. Just it'll take a few seconds to turn off. Accidentally. Huh? No, stop. Go ahead.
So have you ever had a hankering for mangoes in the winter or
Yes.
maybe strawberries in the summer? But no, you can't eat it because these fruits refuse to be grown other than in their main season and it's too expensive to import it from another country. Well, fear no longer. Today, we at Green Forge have created the automatic temperature controlled greenhouse which will let you grow any fruit, anytime, anywhere. I'm the one Rajpura, this is Alok and this is Samveer and today we'll take you through our process and our final product.
So the problem we faced was that we can't have mangoes in the winter, let us say, and strawberries in the summer. And secondly, we also have a problem of food being a little expensive. So we have decided to solve that problem.
To solve this problem, we decided to develop something which can grow any crop anywhere at any time.
Yeah. So our main aim again, like he said, was to make sure that crops can be grown anytime, anywhere through a set of temperature control, making sure you replicate the climate which they're supposed to grow in. This allows them to biologically grow without any issues, not using any unsustainable chemicals or other products which can harm the human body. So our process began all the way back in the pre-residency course, where we got together and brainstormed on this idea. Arav was the one who insisted on this idea. So Arav, how did you get this idea?
So I was actually participating in a city level competition back in the day in 2024 and there I actually won the competition. So now I thought I got motivated that this could be a good idea because I presented this itself in the competition and from there I got the idea. Then we had a pre-residency course where I insisted on we make this. Then once my team agreed, we started working on it.
Yeah. So in the pre-residency course, we created a BOM and planned out the code and design for our product. Before coming here, where as we've all seen this entire process, enjoying learning the different tools. Yeah. I'm sorry. Planning. So planning and then coming to makers where we learn the different tools, played around, learned Murphy's law, and kind of just tinkered around until we could finally get to our final presentation where we finally managed to make our product.
How it works. Our product consists of 3 halves consisting of 5 different parts. In the first half, we have the temperature sensors and the clock monitor.
So the temperature sensor, which is currently mounted inside, is collecting the data of temperature and humidity, which feeds it to the Arduino. Alongside with that, we have the clock module, which keeps track of time.
In our second half, we have the Arduino microcontroller.
So the Arduino microcontroller acts as a brain for the robot. It plans everything out and provides the necessary actions for the actuators.
In the third half, we have the fans and the Peltier module.
So the fans help cool this thing down, and the Peltier modules help heat the whole greenhouse up. So let us say you want to grow mangoes in winter. So what you will do is you will replicate summer's temperature in winter and winter's temperature in summer. So in summer, you're going to cool it down via these special fans, and in winter, you're going to heat it up via the Peltier modules mounted inside.
So what are the main effects which come out of our product? So firstly, it allows the production of out-of-season fruits, which is our main aim. However, it can also provide much easier use for farmers and reduce the cost of fruits up to 150%, since farmers don't have to continuously go around checking crop, and since it's in a controlled environment, there's a less chance of rotting or other diseases or issues coming, making sure it's much easier to produce and has lower and higher yield rates.
Over the 7 days of our residency, we have faced a lot of problems, but eventually we overcame them and created our product. In the end, we managed to build a product which can grow out of seasonal crops in different seasons. And the product can also help it. Over the 7 days of our residency, we managed to create a product which can help grow out of seasonal crops in different seasons. And our product can also make it easier for farmers to grow their crops, as it requires less labor. In the future, we want to implement a water irrigation system or add solar panels to add the use of green energy. We hope
to implement this plan in reality and help farmers to grow their crops better. Thank you.
Good work, guys. Any comments or questions for them? Or any words of, there we go. We have somebody asking a question.
So you used those things. Is the code set in for all the seasons, or is it connected to a laptop which is connected to the internet which feeds it the information?
So currently what's happening is we have the code setting, so the code also has what plant is growing inside, and according to that, it automatically adapts to what is the temperature you want it to be and grow it.
Awesome. Thank you. Great job, guys. Well done. Thank you. Going back. Is stream transformers ready?
Doesn't look
Are you
like
guys ready? No. Okay. Moving on. Coming? Okay. Cyborg Steve, are you guys ready? Cyborg, you guys ready? Okay. Let them go and then you guys next. Alright. Here you go, guys.
Transformer, let's do it. Good luck, guys.
The most common problem we've noticed with trash not being segregated is ignorance, where people don't find enough time or motivation in their life to segregate their waste. So we have made an automatic waste segregator, and this is.
So, what our project tries to do is that we recognize the ongoing challenge of the constant waste that's being disposed and the lack of recycling infrastructure present. So we wanted to create a trash bin that would automatically detect what type of waste you're throwing and then sort it into the right bin.
So, as mentioned before, our solution is basically an AI-powered segregation system, and it basically tackles the problem of improper recycling by using a Raspberry Pi connected with an AI model to use real-time analysis and detect if the item is paper, plastic, or metal. And after this item is classified with the Raspberry Pi connected to a camera, it segregates it to the correct category. And now by reducing the human error and by improving the sorting efficiency, it makes recycling much faster and more efficient.
Here we have two examples of how our project works.
Unfortunately, it's not working at the moment, but we've recorded our process along with it.
Here on our right we have it segregating the metal, and on our left we had segregating the plastic.
So basically how it works is when an object is placed on the disk, it's first noted by the ultrasonic sensor which informs the AI to start analyzing the object, which then sends the data into the servo motor, moving the bottom disk onto one of the corners of the box, and then this servo acts as an actuator, pushes the trash into the desired box.
So the technology and materials we used for the main computer and running the AI model, we used a Raspberry Pi computer because we used it for the small size which would be useful in a trash can. And then we used the ultrasonic sensor to detect when trash was placed on the platform and indicate that a photo should be taken to detect what type of trash it is. Then we connected it to servo motors to move the trash into the right bins. And all of these helped us segregate the waste.
So, stages of our process. So first we started with a version 1 model, which was using a pre-made trash can. We separated a circular trash can into 4 parts and connected the servo motors to see how it would work. But after further feedback, we realized that a circle would not be the most optimal because it would make it unnecessarily complicated. So then we moved on to a box which we laser cut through CAD, and after that we assembled this mount which would hold the Raspberry Pi along with all the sensors.
You guys keep it on top. Keep it on the table so everyone can see.
At first we were having a lot of trouble with our Raspberry Pi. We had software glitches, the process was getting delayed. But in the end, we kept on testing it and we were able to do it. The system was not calibrating, the Raspberry Pi was not connecting, and that is what happened today as well. But it was working, and most probably our next prototype will be much better than this one.
It's the different types of waste, which makes a greater impact on the recycling part of the waste. And this, hopefully, when we make a real prototype, it can be incorporated in schools, workplaces to allow for a more efficient and worldwide segregation process, ensuring a cleaner and more environmentally sustainable world. Thank you.
Awesome. Any questions for them?
You should build a real prototype. I think this has a practical implication. It can actually be, you can implement it at a very large scale in, say, a trash recycling plant. Because one of the challenges will be the cost of it. Nobody wants to invest a lot in a trash tank. So, right, domestic use will be limited, but commercial uses, yes. I think that's it.
Thank you. Any other questions or comments? Okay, thank you very much. All right, you team Cyborg, please. All right, let's get ready to meet some cyborgs. Yeah. Okay, this one's next.
Okay, so our project is about letting people who don't have mobility in their fingers play video games. I'm Nirvan, this is Darsh, and that's Ahan.
So first let's talk about the barrier. What is the problem that people face? So the standard controller and keyboards are engineering marvels, but they're also incredibly difficult for people with low finger dexterity to use because they require high finger dexterity. So we want to help gamers enjoy their favorite video games even if they have conditions that affect their motor control, like arthritis or...
So we chose this project because we all have a passion for playing video games and we want people who don't have mobility in their fingers to do that as well.
We also want to strengthen online communities by making sure people of all walks of life can come together and play video games without limitations and build diversity. So, in order to get the system working, it has four parts actually. The EMG sensor, IMU, processing, and the action on the computer. So first of all, we have this, it's called Apache, and it's a sensor that uses the power of biology, and you attach it on your skin, and every time you flex your muscle, it picks up the electric impulse. This thing goes into an ESP32, which is like a mini computer, and it translates the biosignals coming from the sensor into digital inputs. Now, we can feed that into a Python script, so on the laptop, every time you flex your muscle or move this thing, your character in-game also reacts to it. So we played a game called Minecraft, which is also what we try to make this thing look like. But every time you flex your right hand, it would attack. This one's for jump, and this was to move. The tech stack, first of all, the ESP32, it's like the brain, it handles the high-speed sensor data. We need to make sure it has really low latency because you don't want to flex and then have your character move like 5 seconds later. We have the Arduino IDE. Even though this itself is not an IDE like in Arduino, we use C++. And some of the skill sets we developed when making this project was finding out the actual signal inside the graph. When we flex, the graph that used to came was really shaky, and we didn't actually know which one is a real input, which one is just noise. So we had to figure out what was actual human input. We had to be really resilient because there was a lot of circuitry inside this that we packed inside the box, and debugging was a real thing. And we also have to be really empathetic because not everyone has the dexterity as we have. So they can't hold very difficult controllers. We have to keep it really simple.
Okay, so let's talk about some obstacles we faced along the path. So a big one was the power supply for the IMUs. We were connecting everything to the same ESP32 board, which didn't have enough power to control both of the IMUs and the EMGs. So we had to use parallel circuits to spread the voltage, which took a while to wire. And also, initially while we were controlling simpler games, we were using a different Python library because those took inputs from that library. But once we moved to Minecraft, we couldn't understand why those same libraries weren't working. So it's because 3D games use different Python libraries. So that was one of the problems that we faced.
If they're running a demo today, there's games like Atari Breakout, which is like a little brick game. There's Minecraft. There's many games that you can just map using this. So this is a really usable modular product that fits into any game, and it's really easy to fix it up.
Yeah, thank you. That's our project. Any questions?
Motion sensor something? Afterwards, done.
So what I understand is it's like a remote that you can buy to add to any of your already the game that you're playing, right? It's like another remote that you buy.
Yeah. Like that's pretty much play the game. Movement, looking around, and the sensors for like attack or whatever.
Okay.
Yeah, it's a control.
If you have Parkinson's, arthritis, you can't move your hands exactly on the keyboard, so instead you can use more easier options.
Fantastic project, by the way. You guys have an idea for building something that can make people with normal dexterity play less video games? I need two of those.
That'd be useful. Make it more difficult.
But awesome job, guys.
See, I had a fun video of these guys. Let's see if I can go ahead and play it, because I think the demo is quite exciting. So I hope you guys can hear it. Set it up in the backyard and show it to everyone. Okay, let's see if I can play this video. Here you guys. You can explain what's going on.
Yeah, so those are those little electrodes that stop you. He still has marks from where we stopped them like thousands of times. And I don't know, the camera's not focusing, but there's a game. Yeah, that's the dinosaur game on Google. And every time I squeeze my hand, it jumps.
Amazing, thank you guys. Alright, Geopulse. You guys are next. We're adding some chairs on this side. If some of you would like to come from the other side, over here, that we can grab a seat. Some space over here.
Okay, so how many of you have a favorite food? Well, okay, so what if we told you that that food didn't start on your plate or in the kitchen or even at the farmer's, but actually with the soil? Soil is a fundamental part of creating food and agriculture and etc. And that was exactly our purpose towards making this device. So 73% of Indian farmers aren't aware about their soil. They can't accurately treat their soil. They don't know about the exact amount of pH, moisture, how they need to change their soil for the better. The problem is that in the market, there's no easily accessible and financially viable sources to get these devices. Hence, we wanted to create a device that was cheaper, easy to use, and accurate.
So basically, it doesn't look like much, but you can put it in the soil and it instantly gives you the pH, the moisture, the temperature, and basically it tells you what the soil requires, and it goes straight into an app of your phone. So it's easy to use, it's cheap to buy, and it's accessible to everyone. I think that was the main goal. So I think we were brainstorming during the sessions, online sessions, and we came across this idea. And I think it was a lot harder than we expected it to be. So when we came here, we originally thought that we would use an RTO, which is a kind of a brain for the moisture for the sensor. But after the first iteration, we realized how buggy it is and how it couldn't connect to the app at all. So I think for the last 3 days, we went ahead and we redid the whole project using an ESP. And yeah, I think using an ESP, I think it solved most of our issues. The app started working and it was compact enough to fit in this box also.
So we developed an app where all the information picked up by these sensors is displayed. This is the interface of the app. So the app tells you the temperature of the soil, the humidity level, and how much moisture the soil has, which actually helps farmers grow crops that are suitable to grow in that climate and that environment. In the future, we plan on including AI features to the app, where the app will basically suggest crops that can be grown and regulators to change the soil moisture and pH level. This model is really important as it helps farmers actually grow the right crops without using many fertilizers, which makes the food we eat more organic and healthier.
Also, most of the current ways to test soil involve like sending it to a lab, which costs a lot of money, a lot of time, and you wanted to make something that's quick and efficient, and also cheap. Thank you.
Questions?
So your target market is farmers, right? And that's why you've tried to make a cheaper version for them to be able to afford it. But this looks really small, so it will only be able to test the part where it is insert. You must be having some kind of a sensor that goes into the soil. Okay.
Yeah, do you guys have a quick demo to show them or something? Okay, otherwise, everyone should be prepared with some demos. It'll be nice. But maybe you can do a demo of it outside in the backyard afterwards. That'll be awesome. You can explain it better than Professor. Fast pharmacy. Are you guys ready?
Yeah. Okay. I've been told that my name is the fast pharmacy.
Hi guys. So
there you go. This one's for next.
Hi guys. So our team name is Fast and Pharmacy from the movie Fast and Furious. So we're focusing on healthcare delivery. My name is Abhiraj. This is Dhruv and that's Amina.
So, hospitals in the current age are extremely understaffed and extremely overworked, which means doctors and nurses often face burnout. In fact, we found out on a scale of 0 to 100, where 100 is the maximum fatigue, nurses have a score of 70.17, which means they're near the maximum fatigue level a human can experience. So because of this, often nurses face burnout, and which doesn't only affect the nurses and doctors, it also affects the patients, as it leads to increased error and reduced patient care. So often hospitals are understaffed, and tasks like moving between rooms and transporting medicine are stuff that can just increase the workload for these nurses and can be autonomized.
So this is how we reach our final solution. So first we thought we could use manual path editing where the doctor would edit the path he wants the rover to follow so that the rover could deliver the medicine. But then we realized that would be highly impractical because that would require the doctor to know basic coding, which not many doctors do. And then next we decided to maybe do a tape guided path where we lay out the tape and then the rover would use the camera and follow that tape. But the problem with that was it required machine learning and then the whole hospital would be need to map out with tape. But we realized a better solution, which was our final one, where we mapped out the hospital flows and customized the code for the hospital flows. And it had automated storage where the box would open and close automatically with a camera that would monitor the deliveries.
So at the hardware level, we use the Arduino Nano microcontroller. This acts like the brain of our entire project, which controls the movement of our rover. And this project works on a 4-wheel drive system, all connected to one motor driver. And to power this up, we use a stable 12-volt power supply. Right now, we're using an external one, but in future projects, because it connected to a socket won't be very practical. For future iterations, we hope to use a battery. And as the software, we have, so the Arduino will send a code to the motor driver, which allows the 4 wheels to coordinate for left, right, forward, and backwards. We have an automatic storage unit as well. So this is a 3D printed unit with a rack and pinion system, which opens as soon as the bot has reached the location of the patient. And this ESP32 camera, which we're going to show you how it works right now, it basically allows for the bot to stop when there's an obstacle and basically guide the entire path. This could also be stored, this footage could also be stored using an SD card, but we're not using that in this iteration right now. Now, as I said before, the rack and pinion gears, this is for the precise mechanical components, and it opens and closes according to the needs of the doctor. Yeah.
So a few implications and the impact of our product would be both positive and there would be a few challenges. So in the positive category, the manual labor doctors would have to do would be reduced. Improved patient outcome will also be there because there will be faster and more reliable delivery of like critical supplies. Also the staff morale would also be enhanced due to minuscule tasks being carried out by robots. There would also be increased operational efficiency because of this. A few challenges would be the adaptation to existing systems or the infrastructure and also the maintenance and support along with the initial investments for hospitals that are smaller in size. So here's a code that we believe suits our product, which would be the best way to predict the future still maintained. When we saw a problem we wanted to change and we felt some way to solve it, instead of waiting for somebody else to solve it, we took matters into our own hands. Yeah, these are the process pictures of us just doing work throughout the program. Would you like to go through the data?
First, we started with examining the components we got and putting them together, starting with the motor and display and then we connected it to the motor driver and soldered that all together. Then we began coding to make it go forward, backwards, and turn. And and then we ended up with 3D printing this box and attaching the servo and attaching the camera.
Okay, so the next steps would be advancing our prototype, like refining the rover's navigation and sensor integration for better user interface. The second step would be implementing trial runs in a few hospital environments to gather real-world feedback. And the phase 3 would be expanding our solution to a broader network of healthcare facilities. Thank you.
We would also like to thank all of our mentors who were there with us to support us and help us troubleshoot all the errors that we went through. We really experienced Murphy's Law in real time.
So we had a lot of problems with our motor drivers, and to get them to work, our mentor, especially Rakshit sir, he helped us a lot. Thank you so much.
Thank you guys. Any questions?
Yeah, I have one. I was just curious about did you load maps onto it to try and navigate it?
We couldn't really put maps on it because that would require satellite detection.
No, not just even within the hospital. How did you get it?
Oh, okay. So we just used directions and for how long the rover would be in that direction and delays between the direction. So if it was going right, we had a delay and then tell it to go left. And then
Okay, got it.
Yeah.
Got it.
Is this robot like used so that we can go up and down floors like stairs?
So it would be on one floor, like this floor, but nurses oftentimes get tired just running around rooms, so this would be there for them, transporting like medicine and like devices.
How would it open and close doors if the doors
That's a good question. We can work on it later, but yeah, maybe the doors will be open.
So we could try to implement a system where the ESP32 camera could send a signal if there's an obstacle. So like you said, if there's a door which is closed and it needs to open it, then it could probably send out a sound maybe that would signal the doctors to open it. That was a great question.
But then the doctor would then that would also become more hassle for the doctor.
Next
Me too.
Okay, I have a question. What is the size of this? Like how many medicines? Like this can't be this size, right?
Yeah, so this is just a prototype. We'll probably scale it up a little bit to make sure it can fit most medical
And what
devices.
would the speed be? Because you will need to send it.
Yeah, so it's pretty quick, but
We can demonstrate it for you right now. So it won't really work on the surface, but we can lift it up and show you how fast the wheels would work.
outside, because the code got switched on before. Yeah, we'll show you outside how fast the wheels do.
So the hospital is like really fast-paced and crowded. So how exactly can you navigate through that without talking? Like somebody just accidentally fixes it. It's like so fast-paced that how do I navigate through all of that?
Yeah, so right now all we have is like function calling, so it turns left and right. But later we plan to use the camera as a way to detect obstacles and navigate around them, and just like navigate the corridors much quicker.
A lot of the problems are solved. You can take a Rupa and use that as your motion platform. Stuff on it. Pretty much can navigate by itself. Opening doors, you can put NFC tags everywhere. When the stuff goes by, the NFC tags. So a lot of problems are solved. You just have to stack it on top of each other and build it up. So not a difficult thing. There's always prototype 2 and 3 and 4. So great work. Awesome.
Awesome. Great job. Like Arun said, stacking and at the same time it's a great first step, so amazing, well done. Let's show Walker. Oh, no, yeah, sorry. Oh. Crop circuits. Let's go. This one.
Hello everyone, we are Crop Circuit, we're team 19 and we are practically a combination of team 17 and 18. It's quite a coincidence. So our project is actually a sensor which is mounted on top of a robot for it to towards farmland, and we'll get into more details later.
So in many parts of India, farmers don't decide when to water crops based on soil data. They decide it based on their routine. And studies by agriculture universities and ICAR, the Indian Council of Agriculture Research, have shown that over-irrigation is the leading cause of over-yielding, and not drought. And excess water reduces oxygen at root level, damages roots and washes away the nutrients.
To solve this problem, soil sensors already exist. So why make this prototype? So conventional soil sensors are static and they are vulnerable to damage due to tools, due to weather, and this is what led to our design, which is a farm bot that can move and get sensor readings at different points of the field.
So we have the board ready, we'll just do it and
The readings will be displayed on this
tiny OLED screen of the First, the sensor dispenses into the soil, and it gets reading. After the rack is clear, it after some time, it automatically stops dispensing.
Some you see with the readings are I can show you readings. So the readings can be seen something like this on the screen. I can show everyone here as well. It's a small screen over here.
Which it gives us the moisture level, pH, electroconductivity, as well as the temperature. So some components of this board. So we have two motors of the wheels connected to a motor driver, along with the rack and pinion system. So this was a big problem with our bot initially. The sensor that we had was quite large to measure all four of these readings. So we developed a system connected to a motor where this could be dispensed easily.
We designed this board in CAD and then went ahead by 3D printing it.
We designed a rack and pinion system where the rack is connected to the sensor itself and the pinion rotates like a gear, which moves the rack itself.
And as you can see here in the picture, so we designed a box with the rack at the back and then the pinion is powered by the DC motor.
I'll just explain how the sensor works. So essentially what you just saw was the exact working of it. It starts by being placed on farmland and the sensor will go down into the soil. Then after it's retracted, it will display the readings over here and it will move a certain distance which can easily be changed depending on the size of the field. And every interval will check what the readings are so that the farmer knows if the entire field is actually appropriate for the crop he's trying to grow.
So we actually went to a real farmland and tested the board on different conditions. So this is just the running on the ground.
So I'll just talk about the few phases that we went through. First was conceptualizing. Initially, we had many ideas on how to get the soil sensor in the ground. A few of them were using a robotic arm, crane, but we ended up using a back and pinion system because we found it most efficient looking at the size of the sensor as well as the power of the motor. Then after that, we created CAD files and got these parts 3D printed. Then finally, it was the construction part. We got the base, we got two motors running over here, controlling these two wheels. And we have a motor driver over here which is connected to the two motors at the chassis as well as the motor which is controlling the rack and pinion.
And this future improvements, this upgraded farm board will integrate advanced sensors for real-time data analysis, enabling better decision making and more efficient resource utilization in sustainable farming practices.
We also want to implement a heat map feature where, so basically this board will traverse the entire field and give the farmer a heat map. So this will tell it
areas needing improvement or where different crops can be grown.
Thank you so much.
Hold on, guys. Any questions?
Yeah. So does this prototype can it like map its location, that from which places it has taken the readings, or you have thought of something in your future prototype how to map, you know, the locations, and ultimately that will be an important data if you are.
One of the big issues we faced also, we were which microcontroller to use. Initially, we were facing problem with the ESP32, which was our original plan, which would help us map because it has Wi-Fi features. But for the prototype, we used a nano, and in the future, we would also, like we said, add heat map function, which will actually remember at what position that reading was taken, and it can display it at a map for the farmer to constantly track how his wheel is working. So in the prototype, we don't have that implemented, but hopefully in the future.
But how do you know the location? Are you using some GPS?
With the ESP32, there's an a GPS module.
GPS module.
Yes. Yeah, that will be attached, and that will tell you at what location.
Do you plan to add more parameters other than pH, temperature, moisture, like anything more, like if to know whether the soil is adequately fertilized or not? That is also important part.
So for now we didn't. So for fertilization, I think pH would be a suitable measurement, and I think for now we did not in the future think of more parameters, but we could very well do that.
You should look for more sensors which can actually, you know, maybe because nitrogen content is a very important parameter for your, which tells how fertilized the soil is, or maybe some elements.
So electroconductivity is a part of this which has nitrogen and few other things inside. So it checks how good the soil actually is. But now that we got the packet building system working, we can add more sensors to it as well. So this is for now for the prototype stage, but if you want to implement it later, we get the system working.
Can I add something? Thank you. Yeah. So actually, one of the really cool things about this project I just wanted to mention is that I think maybe you've observed this by now or not, but there are no prizes or any competitions that make it Asylum. Everyone's project is sort of open source, and they're building on top of each other's project. So this is a project that happened a few years back in Waterminder, and a few students have been actually building on top of that project, as you can see. And this one was really important because it allows you to go from just a straightforward project where it's going and checking the soil data, but actually putting on top of the rows of so you can create a heat map of the entire field. This is something which is actually being implemented into the field right now. We're just trying to figure out like how do you actually create heat maps of a full field, decide what to grow where, and things like that. But there isn't something which is actually there that's doing this. And it's beautiful to see everyone working on top of projects to couple up or compound their knowledge to be able to grow faster in terms of coming up with solutions. Nice. Let's go to the next project. Which one's next? I think we have. That was Vector Walker, we just did that. And now we can go on to Sticksmith. Let's go. Oh, I don't have access to view slides. No? Tell me access. Yes, view. There we go. Pick the big button in the center.
Hi. So, So our project is a smart walking stick for the visually impaired. I'm Stavya.
I'm Aditya.
I'm Rakshit. And I'm Ahan.
So over the course of the program, we worked on designing and building a walking stick that uses simple electronics to make navigation safer and more reliable for the visually impaired. So the main problem we're addressing is obstacle detection. In existing solutions, visually impaired users aren't often aware of the obstacles until they physically hit them with a stick, or sometimes their own bodies as well, which is uncomfortable and unsafe. This lack of early feedback can also reduce their confidence while walking and makes them significantly more dependent on others. Due to this, traditional walking sticks are great for support, but they don't actively warn users about obstacles ahead, and that's the gap that we wanted to work on. So our project is designed for people who already rely on walking sticks as a part of their daily routine. We focused on everyday situations such as moving indoors, walking outside, or navigating familiar and unfamiliar spaces. While designing it, our goal was to keep the system simple, reliable, and safe, so it feels like a natural upgrade rather than a regular walking stick, rather than a complicated device on top of it.
Okay, so basically, imagine if you're walking back from home, you're a blind person, and you have some groceries in your hand, okay? And you're holding a normal walking stick, and there's an obstacle in front of you. A normal walking stick, with a normal walking stick, you would have to go and feel the object. But if it's something sharp or dangerous, that's your cane wasted. It's gonna get cut off. But with our smart cane, the ultrasonic sensors help you sense the obstacle in front of you so that you don't end up damaging the product. So obviously it wasn't really easy. Like the software, the hardware, they were all completely against us. So we spent like a whole day trying to figure out if there was something wrong with like the code after we made it, or the hardware, or anything. But I want you guys to guess what the problem was. Any answers? Yes? Any more answers? Okay, so it turns out, no, it's not that, but it's just that Ratchet's laptop just hates it. And the code was completely fine as well as the hardware. All we had to do was just switch it to my laptop. Anyways, so yeah. Okay, next slide.
That's Murphy at work.
So these are the main components in our prototype. So we have the ESP32 microcontroller. This is like the brain, the entire thing. It stores the code, powers supplies the voltage, it controls the sensor that does most of the logic and everything. And without this, like none of this would work. And then we have the distance sensors. This is what's like actually used to find out distance, check for obstacles, and give data to the microcontroller. And then we have buzzers. So this is currently our main method of feedback. So it will buzz with different tones, different frequencies, and different length of the buzz. Since this is currently a prototype, we do intend to add more components in the future, like a full-fledged speaker to give actual feedback, and rechargeable power supply so that to make it more convenient and portable. So then I want to talk about the software development part. So we, over the past 7 days, we've been working like very hard on this piece of code. So every time we needed, we made hundreds of additions, changes, improvements to this code. Every time we wanted to add a component, swap a component, exchange a component, try to fix a component that was previously working, that stopped working, and like a lot of debugging.
Yeah, so all the physical structure of our prototype was mainly done in CAD and 3D printed. So first at the top of the cane, you can see this enclosure. So it was custom made and 3D printed, so it would perfectly house all the electronics, and the sensors would fit through the holes over there. And while making this, we had to make sure that the dimensions were perfectly exact, because even like a small difference in the dimensions could change how we thought of. And we also had to get really inventive, where we designed a secure bottle holder to ensure that our push button contained glass once it was pressed, and the signal was constantly on. Yeah, so in the end, we had to finish the product where we could assemble all the components, attach them on top of each other, and we created a functional support stand and we made sure it's compact and stable. So you would hold the cane like this, yeah, and then based on what the sensors detect, it would give you a signal through the buzzer telling you whether to go left, right, turn back, or keep going forward. Yeah, that's it. Any questions?
How do the blind know how many buzzes means back?
So there's a different pitch for like forward, left and right. So accordingly it's like significantly different to the point where they can tell if the obstacle is in front of them or to the side.
So basically, right now this is unfortunately just a prototype, but we intend to put speakers which can like output English and words, so to tell them turn left, turn right. Unfortunately, we don't have that right now, but in the future we do intend to add like full-fledged speakers.
And even that, like if you're giving it to a blind person, you can just inform them of it. And these signals are really easy to learn, considering there are only like 3 different sounds. Anything else?
We've used it before, like walking up to different walls and stuff, but we haven't asked a blind person to try it yet. Anything else?
Basically, we always use the top of their sticks to see the lens, right?
Yeah.
So, how is they sensing if the other side is
Yeah, so we, right now, we could only do this, but we do intend to add more sensors at the bottom and in the middle and everywhere.
And also the sensors are intended as a replacement for that, so like to reduce the inconvenience. Is there anything?
Anything else?
Thank you very much. Hydroswan. So,
Alright, hello everyone. Every day, millions of liters of water are wasted. I'm sure you all know that, but just a useful fact to know, considering our project was about water. So, what we invented was a smart sink that gives the right amount of water and the right pressure, so that you don't use anything more and you don't waste any more water than you're already using.
So we all know that we've heard all of the PSAs about saving water, but the issue is that it takes a lot of effort to just keep turning off the tap on and off for most of us, and that is why we don't save water. So if there's a way that we can subconsciously save water without even paying attention, that would save us so much water, considering that the average household in India uses 90 liters of water per day.
So the things that our solution includes is an array of sensors to detect changes so that it can give the right amount of water, and then a proper working tap that can mimic actual water flow, and then there is also a display to show the speed of water and the efficiency.
So we started prototyping with a flow rate sensor which displays the flow rate in the on the OLED display. Then we have 4 ultrasonic sensors on the sink which detect how big the vessel is. So if the vessel is very big and all the 4 ultrasonic sensors detect the vessel, then the water pressure will be 100%. But if you're washing your hand or something else, then only one sensor is detected, so the water pressure will be 25%.
And that way you can save a lot more water because you don't need as much water for washing your hands in a big vessel.
And then we moved on to the coding part, which was we had to like write multiple different iterations of code so that we could get the perfect one, so that whenever the sensors detect something, only then will the water flow and at the correct amount of pressure.
So all of our electronics are kept in the sink itself. That way we can make it a modular thing and we don't have to, we can integrate into any sink. So we put everything in this box here and we just put that on the side of the sink.
And then finally we assembled everything on a mock sink that we had, wherein the sensors were placed in a line, and the tap was connected to the pump motor so that all the water could be pumped in through the tap.
So we also faced a lot of challenges while making the project. Like yesterday, everything was working till day before yesterday, but when we assembled everything, nothing worked. Like we made the whole project yesterday. So it was like very challenging, and we stayed up 1 hour more over here to complete the project, but finally we made it. I think we'll show you in the background.
Alright, thank you. Any questions?
Excellent idea. It is actually solving real world problems, especially in a country like ours.
Thank you very
Really
much.
good.
How much do you think about the waterproofness of the component you're inserting into the sink?
For now, the only part that is susceptible to damage when exposed to water is the ultrasonic sensor, which is outside of the range of water splashing. But the other components are waterproof, and you can place them in water, and nothing will happen to it.
And other components are in the box, so the water won't come in the box.
Your hands really dirty, so even if it's like really close and it's like low water pressure, so it's not going to clean it efficiently. So now dirtiness management of the calamity that you included in your society. So what's the point of saving water if it doesn't even do its job, wasting it? You have it what state when you're washing hands, you get lower pressure so that you can get it will be on for a long time to wash your hands, but then there's lower pressure, so that's what we like. Because there's less water.
Time is not a problem in our country, water is.
Awesome, thanks guys. Oh, let's go to the candy machine. Amazing, let's go. Candy browser? Okay, wait, you want me to open up a different presentation, right? Amazing, are you going to bribe everyone candies before your presentation? Okay. Sure. Off you go.
Okay. Good morning, everyone. I'd like to start with a question. Do all of you like snacks? Do all of you like candies? Yes. Okay, that's what I thought. We have candies for everyone here, by the way. So here's the thing. Do any of you find yourself succumbing to cravings, even if you aren't hungry? Snacking just because it's available instead of out of desire or yeah. So our machine is basically a solution to this, and we're going to be talking about its workings today. Okay, yeah. So when watching the TV show or studying, you find yourself grabbing onto some candy snacking because it is available, even if you aren't necessarily hungry. And most solutions, online videos, whatever, they all tell you to just simply have more self-control. But it's not that easy, is it? There's no machine in place which enables you to be able to control your urges. And that is what we intend to implement today. We're creating a machine that assists you in snacking healthily and having some sort of control over your dietary choices.
Okay, so the candy carousel solves this problem by using physical limits instead of just digital reminders. So snacks are stored inside this this rotating carousel, and it can only be accessed like a limited number of times per day, and then it automatically shuts down, and you can't get more candies till the next day. So once a snack comes, we'll show you a video of the working later, but once a snack is dispensed, so it just locks and you can't get more till the next day. Now this is powered by an Arduino Nano which controls the movement of all this, of the motors and the timing as well. There's a DC motor over here, this yellow one you can see, that spins it around. The servo motor over here opens the flap so candy can fall out. And yeah, that's mainly it. All these parts were designed using CAD by Pranav here. So, yeah.
Another thing to keep in mind is that we are not choosing your limits for you. Eat as many candies as you want, but our goal is to enable you to stick to the limits that you set in place for yourself. So we intend on implementing a web-based interface app which would allow you to set a limit of daily candies, and that's how many times you'll be able to open a flap and eat a candy.
You want a slide or slide you want? PDF. Got it? Yeah.
So yeah,
So now we're going to talk about our journey a little bit because we faced several problems and had to...
Lots of problems.
Yeah. Everything that could have gone wrong has gone wrong. And even the things that we thought were impossible to go wrong, that has somehow also gone wrong. But at the end of the day, we got a product out and we're really happy about that.
Let's go. Okay, this is our journey. So this is our journey. I'm Mo.
I'm Kiara.
Yeah.
So these are 3D schematics.
This was our initial idea. This is an AI generated image, but basically what we wanted was a central rod, and when you press a button, there's like a wheel with different sections containing different candies. So this will spin around and it will stop randomly. So a random candy will then fall out, and this is limited. That was our idea.
So we kind of want to gamify the idea so so it doesn't feel like a limitation. Instead, it makes your food eating journey exciting.
Yeah, it's more fun to get a candy because you don't know which one you're gonna get.
Yeah.
Yeah, stand up.
Okay, great. So these.
Okay, so this one in the middle here, this is our first prototype. We were planning on doing it vertically, and it would drop out the bottom here. However, like it was a bit complicated to print and to assemble. So then we came up with an idea where we would have a base like this, and another flap which was the same size as this. And basically this flap would fall down and release your candy. And then as our final print, we're going to do this, but the old motor stopped working. So we had to change the whole thing, and yeah, that's why there's cabling everywhere right now.
Basically, this was supposed to attach on this. So when the candy comes out, it just falls out, you know. It look more static on this as well, and all the ugly wiring can be hidden behind, but unfortunately that doesn't work. So, next. Yes, so we also created a web app like this. So on your phone you can control, you can see how many snacks you had, how many snacks are remaining. Then you can show you whether the machine is on or off, how much battery is there in the machine, and yeah. So this way you can see how much you've eaten. And there's also going to be another, yeah, if you can go now. So this was our electronic schematic. These are all the different components that we were going to use to run our entire thing. This also includes an OLED screen to show you how many candies are remaining for the day, or how much time is left till you can take another candy. Yeah, and there's a timer module as well for the days.
Yeah, so initially we started off with a servo motor, a stepper motor for the rotation, and because of its complications we had to switch to a DC. Yeah, so this is
the
schematic with the stepper motor. The ground.
This took a lot of time to make, but okay, next. What took even more time to make was putting each wire together, because it's so complicating and it's so mixed up. First, before we have to do all this, we have to test every single component individually to make sure it was working, to go through it and troubleshoot it. So our screen unfortunately wasn't working, but luckily we had a replacement screen over here. So after every component, we tested every component and all of them were working. So we finally put it all together. Unfortunately, yesterday, the next slide. So these two are the culprits that sabotaged our project. This is the stepper motor and that's the motor driver. That's basically used to spin the wheel around. And for some reason, yesterday, it just stopped working. We troubleshooted it for hours. Our mentor inductions also helped us a lot, but it didn't work. So we had to, next slide. This was our savior, the DC motor, as you can see here. Because of this, we found a way to make it spin eventually. Next slide. That was a video. Yeah. Yeah, do the video now.
Want to show it to them afterwards, outside?
Okay, sure.
Oh.
Okay. So yeah, these were some of our key learnings. So
Yeah, so after a very long, very complicated and intensive journey, we realized that even if our final product isn't what we intended for it to be in the first place, we still learned a lot along the process, and that is what really mattered in the end. And now we will try to show you a video of its working.
okay, wait, just one thing I want to talk about Lord Murphy. So there's a thing called Murphy's Law. It's that everything that can go wrong will go wrong. Now unfortunately, none of us worship Lord Murphy, even though Weber sir and sir told us to do that from day one. And I think we paid the price for that, because everything that could go wrong has gone wrong. And even the things that we thought couldn't have gone wrong, they've also gone wrong. So yeah, that was a key learning. From now on, whenever we're making something, we'll always worship Lord Murphy first. Yeah. But yeah, and the main learning is that the final product doesn't matter as much as the journey and what you've learned. Yeah.
And yeah, that was our product. If we can please show a video from your laptop.
That's good, yes. I think it's fine. Anyone has a couple of quick questions? Yes.
Okay, just a comment. Firstly, congratulations, very well done to all of you. Just an idea with what was coming to my mind, looking at my industry as well. I mean, what you guys could, besides the candy carousel, what you guys could also maybe consider moving forward is something like a smart pill dispenser. You know?
Yeah.
A lot of elderly people who have multiple medications and things like that. and often, their kids and all, they worry whether their parents have taken the medications or not. So if that could be integrated and connected, and you could have something like that, that I think would be really very meaningful for a lot of people.
That's practical. That's a good idea. Thank you.
Also, is it like it takes out candy after every time you have to snack, like automatically without you using?
There's a button, and that is what triggers your rotation and then your opening of the flap and suspension mechanism. But this button only works after a certain time interval. There's a limit to how many times a day you can press it. So it's not like you can just get as many as you want. That's
And so like if you exceed the time interval, then it only, like say if it's like double the time interval, you can't press one button. What doesn't work?
Double the time interval.
So like if the difference between the time you press it last and the time you are going to press it now is like double, then are you going to be able to press it twice?
Yeah, you can press it twice. As long as you've not exceeded your limit at that current time, you're fine. You can still press it.
Any other question?
Yeah.
Yeah, that's a good question. So
he's coming up with the best question. What's
What is the stop yourself from eating too much?
So yeah, in this model you could. So we were trying to, we were initially thinking of, measuring the weight of the candies and then creating an automatic locking system. So once once it goes beyond the minimum weight, that means there are very few candies, this just automatically locks. And then you can't open it till the next day, but we don't have enough time to make that.
This is a prototype. We will take that into account for our next one.
That's a good idea.
What I'm saying is like, if this is run out, then if you really want more candy, then can't you go and then this
Yeah, you could. Yeah, you have to make sure you put it.
What if you have so much candy that there isn't any space
Then you can't do yourself.
Okay, we'll have to take that into account for our next one. We'll make it bigger so all your candy can fit. Okay?
But that's about control, no? So you shouldn't have so many candies.
Okay.
Awesome, thank you.
Oh, yeah. But am I allowed to press it even after then you're making sure that you have the same amount of candy each day instead of and having less candy.
Alright,
Stay constant.
Yes, so let's say today, let's say that I'm doing this and today you only press it once. So you can like
Alright, and now that brings us to our final team for the... That brings us to the final team, and as you can see, there's been a diverse kind of projects, and I think let's give it up to the last team, that's EuroCube.
Okay.
Let's go.
So where the group this spectrum space, this is the neurocube. The mic is not on. Yeah.
So we're the spectrum spaces and our project is the neurocube. I'm Arya. I'm Kiara.
And I'm Arya. And this is the NeuroCube, it's over there. We're just uploading the code, but essentially the NeuroCube is a cube meant for kids with autism or ADHD. And for those who don't know, kids with autism and ADHD face issues in focusing on specific tasks for long periods of time. And they get distracted very easily. So the primary goal of our project is to augment focus and attention amongst these children who face this disorder which allows them to carry out tasks more efficiently and easily. And as they take breaks, they don't get very distracted with other things. So this can help their focus. And basically, in a nutshell, it involves haptic feedback, sensory stimulation, visual stimulation, and tactile stimulation as well.
Okay, so our project was directed towards children who have autism and ADHD specifically. So normally when we are trying to focus on a larger task, kids with autism and ADHD end up getting distracted. Therefore, that's why we're using our cube to create a small amount of stimulation that helps them focus on larger tasks. So this also enables focus and boosts attention and keeps you from feeling overstimulated or stressed out. We also made sure to do both primary and secondary research on this topic to make sure that our project is specifically tailored to kids with autism and ADHD.
Okay, and so this is how it works. Basically, when you click on these buttons, the ring lights up. And if you click to it once, only one works to prevent overstimulation. And in extreme ends of the autism spectrum, even a slight trigger in like 2 lights at once or some changing colors can cause epilepsy and seizures. So we tried our best to prevent that because kids with autism are going to be using these and we don't want it to be dangerous. So, and there's also a vibrating motor inside to provide the haptic feedback as well. And we've tried to provide some sensory elements just for them to fidget with to calm them down.
So our product has a variety of learning within it, such as electronics, PCB, CAD, and a lot of designing in terms of circuits to provide a controlled sensory input. So as we said, the product is for neurodiverse children, which can be used in inclusive classrooms, therapy spaces, and homes to help calm them down and carry out tasks more efficiently and easily. Because as we mentioned before, they struggle a lot to focus. So through the color-based electronically proven psychology aspects, we've ensured that the cube acts as a sensory input to help calm them down and focus better.
Yeah. So let's just go over the parts that we've used in the NeuroCube. So as you can see, we have 3 NeoPixel ring LEDs, and we've lit them up one at a time in a counterclockwise manner. Then we also use a 3D printer to create the shell, and we use the haptic motor, which is a vibration motor, to create the vibrations. Next, we have the sensory elements like this, and we did trial and error with a lot of things. We used toothbrush heads, we used Play-Doh, but we eventually settled on this rigid material. We eventually settled on this rigid material, which sorry. These are focus on the presentation. We also use soldering to connect the wires to the ESP board and the switches. And we use the microcontroller, which is the ESP32, which is the brain. And we upload the code to the ESP32 and then run it from there.
So as we mentioned, during our entire process, we encountered multiple challenges. The main ones being materials connecting LEDs and our breadboard. So for materials, we faced the issue of attaining accurate materials which align with the needs of our product, which imposed us limitation in meeting the deadline. And next is connecting the LEDs to our product. As we struggled to connect the LEDs because we switched from RGB LEDs to NeoPixel lights, as we didn't have a broader color variety, which again delayed the overall process in finally making the product. And then we had another issue of the breadboard size, where our breadboard was quite large and we wanted to make our product compact and easy to carry. However, the large size of the breadboard hindered us from doing this effective.
And also one unspoken challenge that we faced, mostly obviously, our product kept working one day then stopping on the other. We kept having to check it again and again. And in fact, finance mode wasn't working, but luckily now it is. I think because we've tried to make it so compact, everything, you can't see the wires and everything, but it's all inside of here. So sometimes the wires come loose, and sometimes we need to upload the code again and again, but yeah. those are the challenges that we face.
So here are some of the skills that we learned in the pre-emerging course and that really helped make the cube itself. So of course we used CAD, the 3D printer design for the cube, as it had to be a specific size and shape for to match our elements. Then we had to use circuit design both in real life and online, as we needed to plan out the circuit before we actually connected it to the ring lights to make sure there were no components that weren't working or there were no components that interfered with each other. We used CAD and 3D printing both for the cube. CAD was to design it and 3D printing was to obviously print it. Soldering was a very important part of our cube right now, as we inserted a lot of wires in here. So soldering was necessary to make sure that nothing fell off or nothing broke that could interfere with how our cube was working or the ring lights. And of course we had to use power tools for drilling holes, as one of the problems that we actually faced was that our holes that we 3D printed weren't as large as we thought they would be. So we had to use power tools again to drill the holes, as well as using a glue gun to stick our tactile elements and LEDs.
Yeah, actually because we switched switches, we were using a different type of switch, but that didn't work. And we had already 3D printed the cube with the previous size. We just had to use some power tools to make the holes a little bigger. That's our presentation. Thank you so much. Anyone have any questions?
Yeah.
So inside the cube, you said there was a lot of wiring, right?
Yeah.
So if there's a positive and then negative wires connecting to each other, what if one positive wire connects to the other two negative wires and then the battery short circuits?
For us, actually, in our box, we had to solder a lot of the materials, so it has a less likely chance of a positive and two negatives connecting, leading to the short circuit. But you're right, because one of the problems we did face was that the wires in the box kept unplugging from the breadboard, which would mess with our lights.
Yeah, and your question was basically what happens if it short circuits. It short circuits, there might be a fire of some sort. I don't know. There's rubber insulation, of course, but basically the wire will stop working.
I'm really sorry, but this is the road outside is getting jammed. Anyone has the car number with Karnataka number plate 7745 over here? Or Goa number plate with rental cars 0416, something like this? Okay. Just trying to figure this out.
Okay, yeah, so if it short circuits, the wire will probably stop working. We don't have a battery. That was one of the things we wanted to implement, but we couldn't. We have an adapter connected to a buck converter which changes the voltage from 9 volts to 5 volts, and then it connects to the cube. So in the case of short circuit, the wires will probably stop working. Maybe if it's connected to ESP32, that will stop working. But we tried our best to prevent that, and as you can see, since the cube is working, we don't have that problem.
Any other questions?
How did you know that your cube worked?
How did you know that the cube worked?
Yeah, you tested out.
Oh, so like...
Yeah, so we spoke to a specialist who deals with autism in children, and she told us about the different types of colors and the duration, and she actually reminded us about the epilepsy thing.
We also spoke with a resident maker here, I think he's an alumni, and he also has autism, so we kind of asked him for feedback on the cube and what specifically helps him in general, to make it as accurate as possible.
Yeah, and he also tested it for us.
Yeah. Anything else?
Any other questions? Okay, so yeah, we just wanted to thank everyone here and all the mentors for helping us a lot. Dakshat sir, Tahir sir, Anu, Archit sir, Webber obviously as well. So thank everyone. Thank you.
So sorry about the mayhem outside. I think somebody's parked wrongly and all the honking going on. Well, hopefully we'll figure that out soon. But hey, let's hear it for everyone. It's quite a beautiful variety of projects, everything from something for fun to all the way to make a change in somebody's life. And that's really, really exciting to see. Okay, I have a few things to share. And of course, I have these certificates for you guys. But at the Asylum, it's more about the learning, but we have some beautiful certificates and a few things. So I'm just going to quickly share my slide. And then we can enjoy the Make Break Festival outside. You guys will come at a beautiful time. We have this festival only once in the year, and it happens in December. So, which is perfect. This time it's aligned perfectly with the residency. So it's going to be really fun to have you guys join us for the festival. The festival is where you get to meet a lot of makers from in and around Goa and other parts of the country once again who've been part of the maker community, who've been doing a lot of stuff. So you'll get to see some of their projects and you can also buy some of them. It's like a flea market. Apart from that, there are different workshops going to be happening through the day. We have a workshop by a musician called Duelist Inquiry. There is a workshop with Kamal, who's going to be in the wood shop. All the workshops will start around 1:32, and they'll go on for about 2 to 3 hours. In the afternoon, we have a panel discussion at 5 o'clock on spaces like this, cultural spaces, and what else is happening in and around Goa. So some really exciting folks from Achala, from Goa Jazz Academy, and a few others will be here talking about their perspectives and importance of alternative education and this kind of community spaces and what's happening about that. So please stay back if you have the time. I know a lot of you will have to go soon after this, so that's totally okay, but there's a fun day planned even outside today. Let me tell you about a few things. What's next as part of this journey? Now officially, all of you guys have graduated from M1 level makers. So congratulations once again. As an M1 level maker, one of the big things that it gives you is full lifetime membership to the Asylum. So you guys, this is your home from now. There is no thinking twice. Whenever you're in Goa, this place is yours. Please come back, use it as much as you like. This is home base for you. All of us are always going to be there for you, and vice versa. So that's number one. And of course, you can continue to climb in the maker journey, keep doing more projects, do more things, whether here or at home, and keep sharing with the community. That's how the entire maker ecosystem works. You will also have access to a few other things, like the Discord channels and everything that you can continue to chat with all your mentors, all your peers. And I think you guys saw the power of the community over the last week. Did you feel that? A little bit? Yes? Nice. And I think that's what's essential. It's about getting the help from the right people, understanding how to navigate a community and actually keep building. So hopefully this will be exciting for you guys. Apart from that, there are other programs, workshops, things that we do. One thing is that you can just come back for the residency part again. So we call them level up residencies. So if you want to come back just for the residency, do the same residency part one more time. A lot of students have done that and had a great time to be able to do one more project. You're welcome to do that. We're more than happy to have you as part of that. You can also come back as an alumni mentor and help out other folks if you feel you're ready for that. Level 2 of the Innovation School program is called the Hardware School. Forget the word start. Hardware School. The reason why it's called that is that the program is designed to sort of help you go deeper into the world of hardware and how do you make from having an existing prototype to 10 units. So the idea is how do you go from 1 to 10 or how do you scale up your ideas? That's what the idea of the level 2 of the program is. So if you're interested in that, you can get in touch with us. It's starting at the end of January. The program focuses on how to build hardware going from prototype to product. What you guys just did was idea to prototype. Now, if you're going to want to go beyond a prototype, that's what the program is all about. This is another program that we do called the STG School. This one we've been running for many years. alongside multiple universities and partners from around the world. And the idea has always been to involve folks in working on the sustainable development goals. So the idea is over here that you're working more on brainstorming, thinking, a lot more thinking involved, and of course prototyping, to really see how to work towards one of the sustainable development goals in an organized manner, alongside UNESCO and a few other. UNDP is the one that's behind this program with us, who funds it, and also you're working with UNDP representatives to actually coming up with solutions for different SDGs.
Can I take a 5-second hunch?
Yeah.
We're looking for someone with an Alto K10 Goa 8687. We just need to move it. Please, if it's your car, let us know. Alto K10 8687 Goa.
Yeah. Give me back. Out of there. This is always the fun part. Okay. Alright, already talked about that. You're also welcome to volunteer and intern with a few open research projects. I've shared the board with you, which is an open research project which is going around Goa, understanding where coastlines are. So projects like these, which are open citizen science projects run by the community, are things you guys are more than welcome to get involved with. What can parents do? Fun stuff. So I don't know if you know this, but Makers Asylum was 18 plus for the last 10 years. Only in the last 3 years has Makers Asylum opened its doors to teenagers starting 13 years and above. Before that, we were only 18 years and above. One of the really fun workshops that a lot of adults, average age group around 14, I would say, come for is the woodworking course. So that's another one that you could possibly look at. It's a 6-day long course where you spend time actually deep diving into making furniture and doing things they have. It's a great way to get started if you're excited about spending some time learning something else, something new. It's a very meditational exercise as well. We would also love for you to be a parent ambassador and help us spread the word about the program. It would really mean a lot for us because the only way that Makers Asylum runs is by word of mouth. And if you enjoyed what happened over here, we would love for you to share it with other folks and help us find more amazing students like these to be able to continue doing what we really love at Makers Asylum. Finally, we also have a foundation. Yesterday I spoke a little bit about it with some of the parents, but I can tell in very, very short. The foundation looks at supporting students in this very same program. And the way it works is that we have various companies giving CSR funds to be able to support them. This year we have HDFC Bank, we have Adore, we have GSW Foundation, and a lot of individuals and family members who have supported students into the same program. And why is that happening? The idea is to make this program as inclusive as possible, give everyone the same experience, folks from underserved backgrounds to be able to get the same learning, same program, everything same. The thought is to get 100 students into the program from underserved communities this year in 2026, and that's what we're working towards. We already have somewhere around 26 students enrolled into the program. Just to give you a real life story why it's important. That's Ganesh. He was part of the program in the first batch. Actually, before the first batch, when we were prototyping this program, Ganesh came to us from Teach for India. He's from a third generation background of carpenters, so family of carpenters. Amazing student, but was really not working out for school. And Teach for India, one of the mentors reached out to us saying that please take him, figure it out. But the guy really loves to make things. So he came on board, and we didn't have any funding at that time or anything, but we loved to bring him on board. And not only did he do amazing projects with his hands, but he started becoming a mentor with us. And he started working with a lot of other students, including the ones coming from France and other parts of the world. And then he met this student, Naman, who came from Dhirubhai Ambani and was part of the first batch of Innovation School. Naman then later on started his company called Airborne. Airborne has raised $8.65 million from Lightspeed Ventures and a few others to build airways delivery drones. And Ganesh is the director of tech at that company now. So his mentor has become his director of tech and they met at the program, they met at the Asylum. Beautiful story, and right now they're one of the most talked about hardware startup out of India, being supported by some of the big guys in the field. Both of them innovation school students. that wasn't really the plan behind the Innovation School program, but the fact that something like this is happening is beautiful. Right? There's another few. Anas and Zaveri, they came to us from Dharavi. They were part of the program. They made a board game to play with alphabets to encourage students in Dharavi to be able to become more comfortable with English. And they went to Inventors Challenge this year on Colors TV, raised 10 lakh rupees. They started their company, building alphabets and games. So there's a lot of real stories that have come out of the Asylum, and the idea is to support more such students. This is a short video of the students from this batch, but I'm not going to play that right now.
Thank you so much for
This was in, okay fine, we'll watch it for a second. This is from October. These students were here as part of the same program. And just to
ஏதோ ஒரு ஊர்ல இருந்து ஒரு சின்ன விஷயத்துல பண்ணியிருந்தேன் எங்களை இவ்வளோ பெரிய இடத்துக்கு வந்து இதெல்லாம் கிரியேட் பண்ண வைக்கிறதுக்கு முதல்ல நன்றி. நெக்ஸ்ட் இதே மாதிரி நிறைய பசங்க வந்து இங்க கத்துக்கணும். எங்களை மாதிரியே எல்லாரும் வந்து ஒரு நல்ல ஒரு பெரிய இடத்துக்கு வரணும். அதுக்கு உங்களை மாதிரி ஆளுங்க சப்போர்ட் பண்ண முடியும். நீங்களால தான் எங்களால சப்போர்ட் பண்ண முடியும். அதனால ரொம்ப நன்றி. இதே மாதிரி எல்லாருக்கும் ஹெல்ப் பண்ணுங்க. தேங்க்யூ ஸோ மச்.
थैंक यू सपोर्ट करने के लिए हमें, क्योंकि ये जो मेरा प्रोजेक्ट है इसको मैं चाहता था कि मैं अपनी लाइफ में कभी इसको बनाए हम और इसको यूज करें, क्योंकि हमारे इंडिया में इतना पोल्यूशन हो रहा है जिसकी वजह से बहुत से एरिया में ऐसा हो गया है कि वहाँ पर जो पेशेंट होते हैं उनको फ्रीली रहना मुश्किल हो रहा है। पोल्यूशन की वजह से उनको सांस लेने में प्रॉब्लम हो रही है, ऑक्सीजन नहीं मिल रहा है, और कई जगह पे ऐसा हो रहा है कि उनको ऑक्सीजन सिलेंडर लगाना पड़ रहा है जिंदा रहने के लिए। तो थैंक यू सो मच कि हमें सपोर्ट करें तुमने, और हम ये प्रोजेक्ट को बनाकर लोगों की मदद कर सकें।
So all the students from the foundation have been coming from the October residency, summer residencies and the March residencies now. And this December residency we do not have actually any space to incorporate any foundation students, but every residency now has 30% seats only reserved for foundation. That's our plan going forward, to improve the diversity in the students, but at the same time give everyone that collective, holistic, cultural experience as well to work together. And one last thing, we're working on building our campus in Goa, and that's another big conversation that we're having. We want to really, would love your support. If anyone has some thoughts, please reach out to us. We'd love to talk about it and tell you more about that. This year we've had 400, till now at the Innovation School program, we've had over 400 students from 50 cities across India, 15 countries now, and from 150 schools. So it's been very diverse, and that's, I think, the nature of the program. The idea was to keep it as diverse as possible, because when you get diversity in the room, that's where the real ideas come from. Different perspectives, different cultures, different people meeting. This year it's been 184 students, 50 teams, and we've done 8 versions. That's just a little background. And folks have gotten into some great universities around the world, and we're very happy that it's helping them from a perspective of building things that really matter to them. Well, that's about it from my side. I have a few important logistics to take forward, and one of them is the certificate. So I'm going to call upon your names. We'd like you to come over here and grab your certificate. All the mentors, if you guys can come and help me get the certificates, that would be great. Once I'm done with the certificate, we're going to take a group photo before you guys leave. So we'd love to take a group photo with all the parents and all the students. And finally, do you guys remember your passports? Do you have them? Okay, if you have your passports, you want to get them stamped and signed, you head to the proto space and head to Daksh. Daksh is going to stamp them and sign them for you. How many of you got your t-shirts? Okay. For the rest of you, once again, you can head to Daksh and we'll give you your t-shirt if you haven't gotten your t-shirt. And if you'd like to wear it, you can. One final thing. Once your documentation is complete, we'll be in touch with you to put up your project on the website, and after that, you'll be eligible to apply for the Oshwa license. the open source hardware license. How many of you would wish to apply for that and license your projects now? Awesome, great. So that's going to be again optional, but we will support you through the process to get through an optional license for your project that you can then take forward in your applications and other ways, and always put it as part of your documentation. Well, that's about it from my side. Thank you so much. Let's hand over the certificates. Come. Okay, first, Arav Jessing. Arav? There you go. Okay. Arya Bagaria. Hey, cheers. Would you like to come forward? Ashna Agrawal. Oh, nice. We also have your name tags that you can make at home. Something fun to take back.
Everything, your name tags all in this box that you have already laser cut with your name.
Yes. But you need to assemble them yourself. Oh, there you go. Doing good. Thank you. Come, some mentors, would you guys like to give the certificate? Come, start here. Daksh, come. Aditya. Aditya, you get? There you go. Are you good? Take a photo. Augusta Rajay.
Thank you.
Come. Like photo. Arpan. Okay. Anand, my turn. Would you like photo? Come. Anika, Vicky. Anya Agrawal. Arya Agrawal. Abhirat Pandora. How about we take a group photo and just be here? Because we'll take some time. Over here. Dash. Okay. Group. Two. Ehan. Suja. Vedant. Can't see it. And hi. Yara. There you go. Yara Jen. Yes, the two of them. Nirvan Kalia. Om. There you go. Yes. Pranav. Pranav. Rachit Pawan. Raghav. Samved. Samved. There we go. Sharia. Come. We'll all take photographs once we're done, and then we can go around. Sierra. Savia. Harnish. Wait. Back. Beard. Back. Behan. Up here. Behan. Raj. Behan. Oh, there you go. And him? Can I go, sir? Perfect. Okay. So, how about this? We'll do a quick group photograph so that we can have everyone in this, and then after that we can disperse and go around. All the makers, sorry, 1 second. All the makers, you guys can take your prototypes, and there is a big table like this outside. You can keep it over there, and you can give demos to everyone. Sounds good? You can set up your prototypes on a big table outside afterwards. But first, let's take a photo. Mithun? Okay, we'll stand over here. So everyone can rise. And we'll look at Mithun on that side. Come a little this way. Some of you can sit down.
Why don't you come in? Just come in. Stand behind you guys. You're going to get us always this.
Look at Mithun. All the students in the front, parents will come in the back. And we'll look at Mithun. Please come back a little. Some of the guys can stand on the stool right at the back.
Over there.
Some of us can sit down in the front. Come. Right here. Please gather around in the back. All the parents, if you'd like to come here, towards the back. Let's try and really do this. I know it's a great tool, just to take this program. All the parents also please join us. Let's organize. Let's organize a little bit. Move this at the back a little bit so that you can stand at the back. Just go at the back. There are people behind us. There are people behind you. Okay. Some people at the back. Can you guys come in front? There we go. Okay. Are we making it? Okay. At the Warm welcome, get in. Okay, so at the asylum we say make, break, create. Everyone. At the count of 3. Everyone at the count of 3, we're going to say make, break, create. Okay, 1, 2, 3. Make, break, create. Once again, let's do it again. A little bit more energy. A little bit more energy. Let's do it again. 1, 2, 3. Awesome. Thank you so much, everyone. Oh yes, and don't forget your sugar cube. Take your envelopes with you. Take your sugar cubes with you. Don't forget your sugar cubes.
So